Hi, I'm Dave Burdick, and I'm the director of the Jackson Estuarine Lab, and I've been working on coastal ecology and coastal restoration for 30 years. And my colleague is not an ecologist, but an engineer.
Hi, Tom Ballestero. Welcome to the COVID edition of Living Shorelines. I'm also with the University of New Hampshire, the Coastal Habitat Research Team, along with Dr. Burdick and a number of other profs and researchers. And I am involved with the engineering and monitoring of living shoreline sites such as Wagon Hill.
The property was purchased in the 1990s by the town of Durham. And by 2000, it was pretty clear that there was an erosional problem at this site. And by 2008, we had several meetings to discuss the issues around the site. And by 2016, we actually got down to work because the technical aspects of living shorelines sort of intersected with this and was sort of encouraged us to make this happen, with working with the town and ecologists and engineers coming together, and also state agencies looking for ways to enhance shorelines that are being eroded and also that are going to be being changed by concerned property owners who don't want to lose land to erosion.
An important facet of this project is public awareness, public education, to understand what was happening, especially at the Wagon Hill site, which has a number of different interest groups involved with the overall Wagon Hill site. For our project partners, a kiosk like this was developed by the Stratford Regional Planning Commission, and we had a lot of other partners, but this kiosk basically goes through the timeline of the project from when the property was purchased until when we actually did the construction, goes through the finances and the funding, and then, as Dave was mentioning, some of the issues that were happening at this site. So taking a big broad brush look at the issue over the eastern seaboard of the United States. Most of the salt marshes are under threat from various issues, and there are some estimates that we'll be losing the majority of them by the end of the century. And if we can do anything to preserve or increase them now, that'll only help us in the long run.
I wanted to zoom in for a second to show the original shoreline right here. And if you can't see this, you'll see an image right afterwards. But I wanted to point out an old peat block with some live plants and some non-live plants, and then a large erosional area to the rear of that with actually a tree trunk surrounded by sand. And the town had put a fence up about 22 years ago, I think, and then that got eroded out and fell in, and then they put rocks on top of geotextile and moved the fence back about 20 feet, and then that was starting to fall in. And so that was about 2016. So that really precipitated this whole project. So you can see the erosional area. Tom measured the erosion at this site as about 1/2 foot a year, but it must have been worse than that some years to get that rate that we actually, the overall rate.
Absolutely.
Over the 2 decades.
Absolutely. So we'll show you some erosion pins and how we measure erosion a little later on, but just the movement of the fence was on the order of a rate of about 1 foot a year. The average that Dave just reported is the average erosion rate along this south-facing portion of the system, and locally where we had erosion pins, we were seeing rates of some up as high as 1 foot per year. So the erosive attack hasn't really stopped. There are a lot of culprits that we could point to. Ice, there was a lot of foot traffic, humans and animals on the marsh. The trees that had been far away from the marsh a century ago now were very large trees right over the marsh, shading out the marsh. Sea level rise, boat traffic and waves, and almost every tidal cycle, when the tide goes out, you can see sediment and erosion happening on the banks. So there was a very severe erosion happening here, and what ultimately happens is the salt marsh was being eroded back, leaving in front of it mudflats. And that erosive face was a vertical face on the order of 1/2 foot to 3 foot high. And any vertical face in a hydraulic environment like this is an aggressive point of attack. and therefore this has to be considered when you're actually coming up with the design. How are you going to do the edge protection? What's very, very novel about this particular site is we built out to the shoreline that we estimated we had about 30 years ago. And normally this mudflat area that we built out into would be jurisdiction of either the state or the federal government. So it actually took over 3 dozen meetings and discussions with the citizens, with the town, with the design group, and with all the regulators. It was important to have everybody involved in that room to be able to move this project forward.